Many of us here work on sustainability, on climate change, on biodiversity, essentially about understanding Earth. And what Dan and I want to share here is 3 challenges we see and the solution we propose. Number 1 is that we have a lot of data about Earth, and we keep thinking that more data is the answer to our problems. We keep putting satellites, we keep putting sensors, and it kind of reminds me that friend we all have that has a ton of books at home they haven't read, and they go to a bookstore and they buy 10 more books because they're interesting, that it's really useful data, but you don't have the time to read them all. And part of the reason is challenge number 2, which is that those books are hard to read. Geospatial data, remote sensing, it's really hard to store, to process, to do all of those things. But we know how to do that in some cases. You can go to Google Maps and search how many cities are there in the world, how many hotel rooms are there in Davos with free rooms. The answer is 0, obviously. But there are other geospatial data that is much harder, that we need the answers for when we work on climate change or diversity or other issues, like what is happening with the snow or the tree line in Davos. It would take 3 PhDs and $500,000 to answer that question, and we need that answer for the entire world. And the challenge number 3 is that all of this stuff is risky and is expensive. We've helped build companies, we've helped spend money, public money on these things, and it's expensive. And that is the reason the majority of the market is dominated by trading high risk with high profit, venture capital, or defense industry. And we have built tremendous services, tremendous value add on that. By definition, they are forced to constrain the users of that value by the business model. So the answer of all of those 3 challenges, we believe, is combining, for the first one on the books we haven't read, there is a new tool out there a couple of years ago that, of course, I'm talking about AI, that understands all this data, understands how to transform it and how to bring it up. In specifically, the transformer architecture, the T in ChatGPT. So we are creating an AI model specifically and natively designed to understand Earth and understand Earth data. For the second challenge of making it easy to understand, we are making that model completely available, completely open source, completely open data, and open for business. So that we enable journalists, we enable nonprofits, and we enable startups and companies to build services on top of that.
I'm excited to report that our nonprofit project, Clay, has received $4 million just to get started from Schmidt Futures, from Amazon Web Services, and from the Grantham Foundation. Today, we released Clay V0. The model is posted. Over the next 6 months, we will invest an additional $1.5 million in the compute to make this model bigger, better, and faster for everybody, and to support specific applications in measuring agricultural infrastructure, monitoring biodiversity, and reporting on forest carbon. The people in this room are clearly exceptional at organizing, assembling, fundraising, and building organizations that have transformative impact in science and technology. So help us. Help us to distribute and apply this model to the world's greatest challenges in climate and nature. Go to madewithclay.org and come find us.